All right, let's start talking about quadratic functions from this slideshow. Okay, so we'll run this slideshow from the beginning. We're talking about the quadratic functions, which can come in one of two forms: the standard form ax squared plus bx plus c, or the vertex form a times quantity x minus h squared plus k, where the vertex is hk. Okay, so supposing we had to construct the graph of this quadratic. This is, as you should identify, in the vertex form. Vertex is 2, 3. And that is to imply it's a simple translation of y equals x squared, which we all know what it looks like, 2 units to the right and 3 units up. Okay? That alone will illustrate you the following graph. So here it is. Okay? Depending upon the accuracy of the graph, you might be happy with that. And so x squared, as we know, is usually down here. The vertex is 0, 0, but since we've moved this 2 units to the right, 3 units up, the vertex is now in that location. Now, through the vertex is the line that divides this symmetrically. So if it goes through the vertex and it's a vertical line, it's going to be the line x equals 2, or in general, x equals h, okay? Because the general form would be x minus h quantity squared plus k. All right. So so any point on one side of the parabola, on one side of the axis of symmetry, has an image point on the other side. Okay. So that's going to be helpful when we're going to end up graphing these things. The y-intercept we need to find. Of course, y-intercept always occurs when x equals 0. So you plug x equals 0 in, and you got negative 2 squared, which is 4, plus 3. So the y-intercept is at 7. So right here is the y-intercept at 0, 7. The mirror image point across the axis of symmetry is going to be right here. Okay. Now, the mirror image point means it has the same y-coordinate, mainly 7. The x-coordinate, well, that's depending upon where the axis of symmetry is. Since the axis of symmetry is x equals 2, okay, we have up at this point, the width of the parabola, if you will, is 4 units. 2 units to the left of the axis of symmetry is the y-intercept. 2 units to the right is the mirror image point, which is at 4, 7. And the reason we plot that is because it just gives us a gauge on how wide this parabola is going to be. Okay, so let's move on. Okay, those are kind of 3 points that I always suggest you plot when you're trying to graph a parabola. The vertex, let's go back, the vertex, easy enough to find in this form, the y-intercept, and the mirror image of the y-intercept. Okay, let's do some more. All right, let's graph this. Okay, so now we're going to actually bring up the graph. We'll talk about these things as we go through. Okay, here's the graph. Of course, the vertex is the same. The vertex is 2 3s over 2 up 3, but you'll note that this is a parabola opening downward, and that is mainly because this lead-off term is negative 1/2. It's sitting out front there, so that unto itself will tell you the parabola opens downward. All right. Find the y-intercept. Again, y-intercept is when x equals 0. X equals 0, throw it in here. Okay, you got 2 squared, which is 4, but then you're taking a half of that, which is negative 2, plus 3. So y-intercept is at 1. Okay, the y-intercept here is at 1. The axis of symmetry is x equals 2. Its image point would be 4 units over and 1 unit up. So there's your image point of 4, 1. There's your parabola. The parabola is a parabola which is said to have a maximum point because the vertex is the highest point on the function. Okay, so that's a maximum, which will always be the case when the parabola opens downward. Okay, all right, so we're going to stop this and pick up with a new video momentarily.